Look at this view. 71% of our planet's surface is covered by an unbroken, continuous body of water. From orbit, Earth is defined by these vast blue expanses. We have built our modern world right on the edges of this water. Thousands of miles of coastline host the ports, shipping lanes, and global supply chains that keep human civilization running. Beneath the surface, the density of life is staggering. Coral reef systems alone support thousands of distinct species, forming a massive, interlocking biological network. Now, imagine if every drop of that water suddenly vanished. We tend to think of the ocean as an empty basin. In reality, removing it creates a massive physical void that breaks the stability of the entire globe. There is no explosive evaporation. Instead, the water simply drains away. The familiar blue expanse is replaced by thousands of miles of exposed, rugged rock. Coastal cities like New York and Tokyo suddenly sit on the edges of sheer continental cliffs, looking down into unlit abysses that drop thousands of meters. Cargo ships, submarines, and massive fishing fleets plummet to the seafloor. Billions of dollars in global infrastructure sit useless on dry mudplains far below our established shorelines. Without the water, our map of the world is erased. The Earth instantly becomes an impassable terrain of jagged peaks and deep alien valleys. Descending into these new empty basins reveals the planet's true topography. We see mid-ocean ridges stretching for miles and towering underwater volcanoes that have been hidden in darkness for millions of years. Down in the Mariana Trench, you would be standing in a valley nearly 7 miles deep. The scale of these chasms dwarfs any canyon we have on land. But exposing this terrain creates a massive physical problem. The oceans are incredibly heavy. Millions of tons of seawater constantly press down on the Earth's crust, acting as a planetary weighted blanket. This cross-section shows the Earth's crust and mantle. Subtract the immense weight of the ocean, and the crust responds. Physical pressure vectors rebound upward. Without that downward force, stress fractures rip across plates, fault lines shift, and volcanoes vent along the newly exposed crust. The ocean water does not sit passively on the surface. Its sheer physical mass anchors the geological and structural balance of the entire planet. Above ground, the atmosphere reacts just as violently. The dense marine clouds that usually blanket the coasts dissipate entirely, taking the coastal weather systems with them. This map highlights the oceans acting as a global heat sink, absorbing extreme solar radiation. These thermal currents operate like a global conveyor belt. They pull trapped heat away from the equator and push it toward the freezing poles, balancing the planet's temperature. Remove that system, and the temperature swings become lethal. The equator experiences scorching daytime highs, while nightfall plunges those same regions into deep freezing lows. The ocean is our global thermostat. Without it, the Earth loses its ability to regulate heat, making the surface atmospherically uninhabitable. Beyond temperature control, the ocean is the starting engine for our planetary hydration. It holds 97% of the Earth's available water. Water molecules evaporate from the ocean, gather into heavy rain clouds over land, and flow back through river systems. Breaking this loop stops evaporation at the source. Rain stops entirely. Inland rivers dry up, and lakes rapidly shrink into isolated pools. This immediate drought triggers the total collapse of marine ecosystems. Highly evolved apex predators, like these humpback whales, instantly lose their habitat, leading to a massive extinction event. That biological collapse hits the shore immediately. The heavy industrial fishing fleets and global food webs that rely on harvesting marine ecosystems fail entirely, severing a primary food source for billions of people. Terrestrial life survives only because the ocean drives both planetary hydration and the global food chain. Remove it, and land-based survival becomes impossible.
From space, we watch the empty basins fill back up with water and the swirling white atmospheric clouds return. The global deserts vanish, replaced by temperate coastal environments and a thriving, active marine biosphere. We often only comprehend the monumental value of a system when we are forced to imagine a world without it. These oceans engineer the specific biological and atmospheric conditions life requires. Protecting them is the only way to protect the planet itself.